For 24, guys, the easiest way to do this is to just graph it. Here's x, here's y. 5, negative 2 is going to lie 1, 2, 3, 4, 5, down 2, right here. And it says a horizontal line, so let's draw a horizontal line through that point. Of those 4 answer choices, which is the only other one that's going to lie on that line? G. Why? Which coordinate's the same, the x coordinate or the y coordinate? The what? The y, very good. Both their y's are negative 2. Do you see that? This horizontal line is always y equals negative 2. So negative 5, negative 2 would be to the left. 1, 2, 3, 4, 5. And then down 2. So this would be our point. So absolutely right, G is our only other option. If you were to just plot the other points, you would also see, okay, that is the only one that lies on this line, okay? 5, 2 is somewhere over here. Negative 5, 2 is somewhere over here. And 5, 0 is right over here. So this is the only one. None of those work. Questions? Okay, let's do this. 5.8, put your name, and let's get started. Okay. Our objectives here are to graph an absolute value function and to translate the graph of an absolute value function. So not only are we learning about what the absolute value function looks like on a graph, but we are also moving it around. Okay, so we're going to translate it a little bit. I need some people to help me out by telling me some pieces of information about what this graph looks like. What do we see in the graph below? Roy, give me something. It's a negative and a positive line. Giancarlo, give me something. Anything?
He kind of just said what I was going to say.
Oh, okay. Anyone? Roy, what else do you see? They are not parallel. There's something else. Perpendicular. Very good. The lines are perpendicular. Okay. We don't have to be that. That was very, very, like an awesome observation. Think more basic, guys. What else do we know about this graph?
There's 2 lines.
2 lines, yep. We said a negative and a positive line. Very good. Where do they meet? They meet at 0, 0, the origin. Let's put that in there. Meet at 0, 0, or the origin. What else? What kind of shape is it? It's kind of like a V, right? So let's put that in there. It's a V shape. And I would say that's good enough. Okay? It's good enough. Okay? This is the absolute value function. Okay? And we're going to talk all about how it comes about and how we're going to translate it. Okay? So let's move on to the next slide. The absolute value function has a V-shaped graph that opens up or down. The parent function for a family of absolute value functions is y equals x. Absolute value of x. A translation is a shift of a graph horizontally, vertically, or both, and the result is a graph of the same size and shape, but in a different position. Okay? So a few things I want you to write down on this slide. We're not going to learn about them right now. We're going to learn about them in a second. Is just write down y equals negative absolute value of x. This is where your v becomes upside down. And the next thing I want you to write is y equals absolute value of x minus 1 plus 3. I want you to highlight this area between the absolute value and highlight the area outside the absolute value using two different colors. This blue region we're going to call opposite world. And this green region we're going to call the normal world. Now, right now, you just need to know what they're called, okay? We've got opposite world, we've got normal world, and y equals negative x is the upside down. Okay. When we translate, okay, a graph of y equals absolute value of x, take a look at this graph on the left. That is the regular y equals absolute value of x. The graph on the right is y equals the absolute value of x minus 2. What happened to our graph? What happened to our original graph? That our right graph looks like that. Roy, what happened? You moved down 2 spaces. You moved down 2 spaces. So write that in there. Down 2 spaces. And that negative 2 or that minus 2, is that in the real world or the opposite world? Real world. So when it's minus a number, right, you're moving down that many spaces. When it's plus a number, you're moving up that many spaces. That's in the real world, okay? Things change for the opposite world. We'll get to that. But in the real world, when it's outside the absolute value, you're moving up or down, okay? And you're just going to follow whatever it says. So if it's minus, it's down. If it's plus, it's up. What's up, Roy? Yes, it will always be that V shape. Okay, take a look at this graph. How is this graph different from y equals the absolute value of x? What was the change in the graph? Someone other than Roy. Giancarlo, what happened? Went up, how many? 4 units. Plus 4. So y equals the absolute value of x. What do you think we add to x? Plus 4. That's it. Okay, moving on. So anytime you're adding k, it's a translation up, as long as k is a positive number. Whenever you're subtracting k, as long as k is a positive number, you're moving down k units, okay? So your translation is either up or down as long as you're in the real world, okay, or the normal world, which is outside of your absolute values, okay? Graphing a vertical translation. So when we have y equals the absolute value of x plus 2, all you do is shift your graph 2 units up. What's up? Yeah, you can go to the bathroom, okay? So we're going to move every single point up 2 units, just like we did. I like to just move your origin and then just draw the same V shape from there, okay? Next, we're going to talk about what is the graph of y equals the absolute value of x minus 7. What happens here? How are we going to shift our graph? Roy? Down 7. Okay? So our graph, here is x, here is y. If we subtract 7, here's our normal point, right? We're going to go 1, 2, 3, 4, 5, 6, 7. Put a new point here, and we've got our V shape from there. Oops. Down 7. Okay, questions so far on moving up or down? Okay, the next thing we need to know, guys, is moving left or right. And this is where we involve the opposite world, okay? So opposite world tells us if we have x plus 2 inside of our absolute value, we're not moving to the right anymore. We're moving to the left, okay? So notice how our graph over here moves 2 units to the left, minus 2, okay? Over here, we have y equals x minus 2. Is the minus 2 in the normal world or opposite world? Opposite world. So instead of moving to the left 2, where are we moving? To the right 2, okay? So now we move to the right 2 units. Plus 2. Okay? That's why we call it opposite world, because anything in there, instead of moving where we normally would, you're moving in the opposite direction, okay? Okay, let's do some more examples. What is the graph of y equals the absolute value of x plus 5? We move to the left 5 units. So in our graph, this is going to be minus 5 units to the left. Okay, let's do a few more examples. So y equals the absolute value of x minus 3. Y equals the absolute value of x plus 2. And y equals the absolute value of x minus 7. What's the shift in the first one? Tessa? Right, 3. Beautiful. Why to the right and not the left? Good. So normally when you subtract something, you move to the left, right? In this case, it's opposite world, so we move to the right. What about x plus 2? Left 2. And my last one? My last one? Right 7. Correct. So you see how, Nicole, for that last one, it's x minus 7. Normally when you see x minus 7, you think of moving to the left 7 units, right? Instead, since it's between the absolute values, that's opposite world. We're actually moving to the right 7 units. Okay? All right, guys. What is the graph of y equals x minus 5? Well, what's our shift? To the right 5. So let's take a look at our graph. Here's our y-axis, here's our x-axis. 1, 2, 3, 4, 5 units to the right. Let's move our point 5 units to the right, and our graph looks like this. Notice how the v stays the same the whole time, right? We're just shifting it around. We're not changing the shape of it. Okay, one last thing I want you guys to write down on this slide is you can, what we call this point, where the two, like the bottom of it, the bottom of the V, that's called our vertice, or vertex, okay? And that point is just gonna be the shift that you did. So we moved 5 units to the right, right? So that point is gonna be 5, 0. Our vertex is at 5, 0. Now, we're going to run through a few other examples. Y equals absolute value of x plus 3 minus 2. Y equals the absolute value of x plus 1 minus 1. And y equals the absolute value of x plus 3. Okay, for the first one, what shifts am I doing? I'm doing 2 shifts. What are they? Roy, give me one of them. Left 3. What's the other one? Down 2. What's my vertex going to be? So if we move left 3, Roy? Negative 3, comma, negative 2. Okay? It's whatever you did. So left 3 is negative 3, right? And then going down 2, that's your y coordinate, is going to be negative 2. Let's try another one. X plus 1 minus 1. Someone other than Roy. Tessa. Beautiful. Left 1, down 1. What's my vertex? Mm-hmm. And my last one. Y equals absolute value of x plus 3. What's the shift here? Giancarlo? Up 3. Anderson, what is my vertex? 0, 3. How'd you know to put a 0 for x?
Because we didn't go left or right.
Correct. We didn't move left or right at all, okay? We only went up 3 units. Okay, how are we feeling so far about the absolute value function? Pretty good? Okay, all right. This last part is not on the GIM kit, but we need to know it, okay? This last part is not on the GIM kit, but we need to know it. So don't just check out right now, just pay attention. We're not gonna write that many notes, I just need your focus right now. The last part that we're gonna talk about is what's called a piecewise function, okay? So go ahead and copy down that word, or that phrase, piecewise function, and a step function. Piecewise function, what we just learned about, which was an absolute value function, that's a form of a piecewise function. What a piecewise function is, it has like more than one distinct part. So normally when we talk about a function, we're like, oh, it's like a nice, easy looking, like curvy kind of thing. Piecewise function is not. It's like broken up. It doesn't have like a fluid. It's not like as fluid as we would normally think. Okay, it's got different parts. And a step function specifically is what we're seeing on the right. Okay, that is another form of a piecewise function. And it kind of looks like stairs, right? You're going from step to step to step. Okay, a lot of word problems will involve step functions, and we'll see one just below in a second. Okay. A school will charter buses so that the student body can attend a football game. Each bus holds a maximum of 60 students. Make a graph that models the relationship between the number of students X that go to the game by bus and the number of buses Y that are needed. If you have 0 students going to the game, how many buses do you need? 0. So we have a point 0, 0. If you have 1 student going to the game, how many buses do you need? 1. Very good. So that's where this part starts. Okay? That's the first part of our step function. So between 1, if you have 2 students going, you still only need 1 bus, right? So it's going to remain at 1 until how many students? At 60, you still only need 1 bus. 61. That's where you make this jump up to the 2 buses, right? So you're going to stay at 2 buses until you get 120 students. And then you're at full capacity for both buses. How many students will you need 3 buses then? 121. Okay? So at 121, you're going to need how many buses? 3. You stay there until how many students? 181. At 181, you jump to 4 buses. Okay? And then from 4 buses, you stay there until what number? Not 21. 241. Okay? At 241, you remain at 5 buses until 300. And I'm assuming 5 buses is their limit. Okay? Why is there an open circle? Why is there an open circle?
Because that's your max capacity for that bus.
Okay. Getting close. That's the point where you're changing, right? That's the max capacity, just like Roy said, at that number of buses. So for example, at 4 buses, right? This endpoint right here is shaded in, right? Because at exactly 240 students, you would still be at 4 buses. But when you jump to 5, only at 241 do you need an extra bus. Okay? So that point, 240, is going to be an open circle when you jump to 5 buses. Okay? All right, guys, let's go ahead and turn in these notes. Now, the GIM kit today is a little bit different. I need you guys to click on the class link in Canvas. So there's a link in Canvas that I need you guys to click.